Now let's move to another important register that is about machine interrupt delegation register. As I explained in the previous lecture, all the kinds of the exception are taken to the machine mode by default. But this is also applied to the all type of interrupt in RISC-V architecture. This is the default setting. So if you do not modify any bit fare inside machine interrupt delegation register, all types of the interrupt are taken to the machine mode. This slide shows you the control flow by default. So when the interrupt occurs in the user mode, but at this point, the software is running in the user mode. After the interrupt happened from the peripheral device, at this point, RISC-V hardware generate a synchronous trap. The controller is moved to the trap handler in the machine mode instead of the supervisor mode. This is a default setting, as I explained it. This slide also shows you the interrupt occurs in the supervisor mode. When the software is running in the supervisor mode, where Linux kernel is running, then RISC-V core can generate the asynchronous trap. Please note that asynchronous trap can be caused by the interrupt. At this point, the controller is moved to the machine mode, moving to the trap handler in the machine mode. So this is the default setting, the control flow. If you do not modify any value of the machine interrupt delegation register. Just like any type of exception, the interrupt is also handled in the supervisor mode in the Linux operating system. For this, so all type of the interrupt should be delegated to the supervisor mode instead of the machine mode. For this, we need to understand the layout of the machine interrupt delegation register. So bit position of the machine interrupt delegation register has similar pattern of the machine the exception delegation register. Please look at this. So this register has this kind of bit layout. We need to pay attention to the first bit position and fifth bit position and ninth bit position. So this bit position is corresponding to the value of the exception code. So this table outlines the exception code when the RISC-V core generate a synchronous trap. So this value indicate the highest bit inside the supervisor code register. Please note that exception code can be updated to the supervisor code register. Supervisor code register also called as code register. But here is the value of the exception code. So right after the supervisor software interrupt is triggered, so the value of the exception code is 1. So what I mean is the value 1 is updated to the supervisor code register during generation of a synchronous trap. As for the supervisor timer interrupt, and as for supervisor external interrupt, for those cases, so 5 value can be updated to the supervisor code register, and 8 value can be updated to supervisor code register. So this value 1, 5, 9, supervisor software interrupt, the supervisor timer interrupt, supervisor external interrupt. All this value is corresponding to the bit position inside the machine interrupt delegation register. So if you turn on the first bit inside machine interrupt delegation register, this interrupt is delegated to supervisor mode. But if you do not modify the first bit of these registers, so by default, this interrupt is taken to the machine mode. But this rule can be applied to another the type of interrupt. So as for the supervisor timer interrupt and value of the exception code is 5. So if you turn on the fifth bit as the 1 in this case, so this interrupt will be taken to the supervisor mode instead of machine mode. But this rule can be applied to the supervisor external interrupt. The bit position is 9. So if you configure the value of the machine, the interrupt delegation register, it will affect the control flow of the trap operation, so in terms of a synchronous trap. Please look at this slide. So in the first step, the software is running in the user mode. At this point, interrupt may occur in the peripheral device. At this point, RISC-V core will generate a synchronous trap. Then after we modify the value inside this bit position, interrupt will be a synchronous trap is taken to supervisor mode instead of the machine mode. So in the Linux operating system, it is important to think about how a trap is delegated to the supervisor mode. The important point is in RISC-V architecture, by default, all types of the exception, all types of the interrupt is taken to the machine mode. This is default operation. But in Linux kernel, the Linux kernel is running at the supervisor mode. For this reason, all the type of the exception or type of interrupt should be taken to the supervisor mode. This is the main reason why the RISC-V architecture defines the machine interrupt delegation register. Now that we understand two important individual, the control status register, the next lecture will perform the interesting debugging practice using trace-redo debugging program.